Hello, welcome to another installment of the Rogue Entity RTS series. In this video we're going to implement basic movement for our characters. If you haven't done the previous episode, I'll be starting off post selection being implemented and also the enhanced input is all set up. After this episode we should be able to move our character around at different speeds. So we've got a bit of sprint, we've just got a normal jog, and we've got a walk. And we'll also be able to change their direction by dragging at the end. So if we want them to face away from the camera, we can drag upwards and they'll turn to that direction after arriving at the destination. To get started, we'll set up our input actions, and we're going to have a command move for each, just a standard right mouse click, holding shift, holding alt, and holding control. So I'm just going to duplicate one of these, and I'm going to call this command. So we've got an IA command. I'm going to go into shift, duplicate this, shift command, duplicate again, alt command, and duplicate again, control command. And in our context, go into default, and we'll add a new mapping, and we'll add our standard command, which was IA command, and we'll set that to the right mouse button. We'll do the same for shift. Shift command. Alt command. And control command. If you don't have the same setup as me, or the videos to do the input action setup is in the top right hand corner. Alright, the next thing we want to do is create a new C++ class, and we're going to create a AI controller. I'm just going to call this S AI controller because that's the prefix I've been using, S, and I'll just put this in an AI folder. And then the other thing I want to create is just a data, basically a data container, just AI data that they're going to need for different things. So it'll grow in size as we move along, but I'm just going to call this AI data. It'll just be a H file where this is where I'll put enums and structs to store different stuff that just the AI is going to use. And this will let me store any. Actually, I'll just leave that in the root directory. This will let me include it in any class that needs to reference any of the data easily. You can either create it in here, or if I create this class, it's going to create the H file and the CPP, which I don't really need a CPP for this, but you can just delete it. Or you can, if you know how to do it in your editor, then you can do it directly. So to do it like this, I'll show you this way, and then I'll show it in the in Writer as well, because you don't actually need a class structure. So this, we don't need any of this. Don't need core minimal. We will need it generated, so just stick that in there. And you can delete the CPP file. If you want to do this same setup just in here, all you have to do is go add and add a file. So don't do an Unreal class, just do add a file, and then just name it, .h, and it'll add just a blank .h file, and you can set it up the same. This is going to have our data that we need for all AI stuff. So the first thing we'll need is a command type. So we're going to have different right-click move commands, and we just want an enum to name those moves. I'm just going to add a enum, make it blueprint type, because we do want to use it in the editor later. There's actually a command type already in Unreal, so that's why I've got the command prefix on all these, just so it doesn't clash. But this is the attacks. We're going to be setting up these three today, and I'll go into this one at a later time. But it'll be just a normal move. We're going to hold Shift for a fast move and Alt for a slow move or a walk. So the other thing we're going to need is a struct. So this is going to be like the data we use to pass around our command that we've initiated, which will be our move command. Have our F command data. And this is going to have a number of properties that we're going to use. So it's going to have the location of where we clicked, the rotation of where we drag. So we're going to be able to hold the right hand mouse button for a move and drag in a certain direction. Then the character, when they get to that destination, they'll face that direction. We're going to pass the type of move. So that's one of these. And this will be used later for when we're doing an attack move. We're going to need a constructor for this. I'll create a blank constructor. So this means you can just do, F command data bracket, and it'll create a struct for you that's empty. I'm not sure if we probably won't use that, but it's always good to have one. And then I'm going to add another one where I can pass in all the variables that I need. So I can create it and pass all the variables. So I'll pass in the location, rotation, type, and I don't have to, I've set it up so I don't have to pass the target there. It'll be null pointed by default passed in. That's all we need in the data for now, so we can actually close that off. I'll just fix this. So we'll come back to the AI controller. I'll actually jump to our player pawn, and we'll go back to setting up the controls implementation. So what I might start with actually is if you followed the enhanced input, I was using a data file for all the inputs. So this player input actions, and this has a reference to all the inputs that the player has. So here I want to add in the command one. So I'm gonna just copy one of these, change it to command. So that'll be our IA command reference there in the default context. And then for shift, duplicate this one, and this will be shift command, alt command, and control command. So that's all we'll need to do in there. We just have to remember to assign those input actions to those variables when we go back to the editor. Before we do those inputs, we bind those inputs, we'll create the functions that they're going to link up to. So we're going to need, go down to our input functions here. We're going to need two commands for the initial. I'm just going to copy one of these, and then so for the command, we're going to have a command start, and this will be a function that all of them call just initially to set the position of where we've clicked, and that's to do with setting the rotation later. And then this will be the straight command, so this will be the IA command, which will actually call when you release the mouse button. And then we need to do the same for the others. So we just need it's basically a command end, but since we're only going to have one function, we'll just call it alt command. I think I missed shift command. Where's shift? Shift. Alright, we'll just implement those functions. And now we'll go back to the setup player input, and we'll bind those actions. So we're going to need a simple setup here. So what the simple setup does is it binds two functions. So when you trigger and then when you release. And if we have a look at this template here, so it's going to bind when the input's triggered and when the input's finished, or it'll be when it's released, when you release the mouse button, so it's completed. So we'll just copy one of these. And now this will be input or shift, so it'll be shift command. This will be, so this is where I was saying all of them are going to have the start, command start. And then this will be the one for the shift command. So I'm just going to copy this. I'll do the base one, default. So this will be just command start and command. Let's copy that one. So alt will be alt command start, and command, or alt command was it? Yep. And then for the last one, be control command start and control command. Right, so now we're not going to need a few properties to set up this. So I might create a new section above the actual input here for any command stuff. So the first one we're going to need is the command location. So that's where we first click with the right click. And then we're going to need just one function additional to the binding. Create command data function. So this is going to use our command data that we set up in the AI data. So we include that. Include AI data. And then in this function is where we'll create the struct with all the data that we need. We'll come back to this. We'll set up the first command start function first, because then that'll make more sense. The initial location. So for this, we just want to check that we've got our player controller reference. It's not null for some reason. We're going to set the command location to our current mouse position on the terrain. So this is where we want the character to move to. And then for our actual command, we're going to call, we have to check our player controller reference. We're actually going to pass over the created command data like that. So this is where we apply what type of command move we're doing. And we haven't set up this obviously in the player controller yet, but this is practically the only difference in each of the commands. So shift command, it's going to be sprint, so we can go command move fast. And in this one, what's this alt command, we'll make that slow. And then the control command will be the attack one that we're going to set up at another stage. So that's pretty straightforward. So you can bind any of those alternative key presses to whatever command you want it to be, really. So that's sort of up to you what you want to do there. I will just, because I'm going to set this up for multiplayer, I'll just explain why I'm going from the player pawn to the player controller and what I'm doing. And I don't really want to go into, a full-blown Unreal multiplayer networking conversation, but the way that moving a pawn in a server client setup that Unreal has is you need to obviously RPC to the server and request to move that pawn. So what we're going to do is we're going to do that on the player controller, because what you'll need in multiplayer for like technically AI controlled characters is you need an owning connection, and that's our connection. So if you RPC just to the AI character and then that tried to tell the server, hey, I want to move, run into issues where it doesn't have an owning connection. And this is because the server has the rights to move them and do whatever. This is to stop cheating, basically. So I can't just say, hey, you shot here and, oh no, actually my unit was over here because, oh, I've just moved it. Whereas server will say, no, you didn't. It was there and it was hit, sort of thing. So the way I'm going to set up today is it's going to be an RPC across on the player controller, and then on the server the player controller will tell the unit to do the move, and then the unit will interface with its controller to organize the move basically, and then obviously that position is replicated to all the players of where it's moving. You won't see this. This is only a virtual thing, like there's still only one player controller. It's just that it'll be done through an RPC, and you'll see what that means. So before we go to the player controller to set that up, I'm just going to go back to our create command data function here. We basically want to set all these. So we're going to need a rotation. We already have the position, so the position will be our command location that we just set. So that was set in the command start. So here we're setting the command location to the mouse position, so that'll be our location to move to. So if we create a new, so we're going to return a command data, and the first thing we're going to pass in is our command location, and then we're going to pass in the command rotation, which we're going to edit in a second. And then we want to pass in the type, which is passed into this from whichever function's running from the input. You can see there it's not going to error because I didn't pass in an actor, the target actor, because it's just setting it to null pointer by default. Actually, what we'll need here is we'll need to check that we're going to need to reference our player controller to get that position on the terrain. So we'll just return a blank. There we go. We are going to use a blank of command data. So that reference to the player controller is what we're going to use. So we're going to get our current mouse position on the terrain when we release the mouse. Press the right mouse button, which will store our move position, and then we'll move the mouse in a certain direction that we want them to face, and when we release the mouse button, it grabs that position. So this will be that end position, and we're going to use that to calculate the rotation that we want to face. In case we don't drag or anything, we're just going to set the rotation to 0, or keep it at 0. So I'm just doing a check here. How far do we drag? If it's bugger all, then just skip this part and keep the rotator as 0. So to calculate the rotation, we're going to have to get the angle, and we can do that by getting the direction and then using a radians to degrees and tan2 to get the rotation angle from that direction. And then we're going to convert that into just a rotation on the z-axis. So we're saying what direction are we pointing? That's the yaw there, so that's what we want to affect, which is the z-axis. And then we're passing that into our return for the command data. So now we can head over to the player controller. So in here we're going to need a couple of functions. So we're the one that we're just sending in. So we're going to need a command selected. The reason why I'm setting up this area is this will grow over time and it'll get hard to find things later on. So we're going to need two functions here. We're going to need a public one, which is being accessed, which is command selected, which we just said. And then we'll have a protected one, which is the same function, just it's going to be server. So this is our RPC that I was talking about. And to set up a function as an RPC, we just put in here what type of RPC it is and whether it's reliable or unreliable. There's a third variable you can set there to be validated. We're not going to do that for this. And we need to add our AI data because we're referencing that. I'm just going to include that. And you'll see that when you do the definition for this, it has the implementation on the end. So if you're not auto generating this definition, then make sure you include that implementation on the end. And what we're going to do here is we're going to just check as authority, even though we just RPC'd to the server, we just don't want anyone running this. They're not the server. So what we'll do is we'll just say not as authority and return. And then in our command selected, we're simply just going to pass this onto the server and pass on the command data. So think of this as like a gateway to issuing a command, and this is going to handle passing it to the server. So now on the server, what we want to do is say, okay, so all the units that we have selected, we want to issue a move command on that character. So we're just going to do a for loop over our selected, cast it to the character. So if you're using a different character than this lovely name here, cast to your character, and then we'll call a command move to location on the character. And again, we're just passing on the command data, which is just a nice easy way to have a bunch of stuff pass through without having all these variables in every function. So that's it for the player controller. Pretty straightforward. It's going to have this error until we set up the actual character. So I'm going to jump over the character now. This is probably going to be the biggest one. Again, I might just copy that, set up the same section again. I'll set it up down the bottom this time. So let's start off with that command move to location function we just issued to make sure we get rid of that error. And again, we're going to have to include our AI data. So that should have fixed our error over here. I'll just implement this one. So this is the reason why I'm going through the character rather than go straight to like the AI control or anything like that, is if you pass through the character, then you can either grab settings or apply settings to the character that you need to do. And for us, obviously for this, we want to apply a different move speed. So what we're going to do, we're going to just do a switch. So we're going to switch on the type of move that we want to do. In the command data, we have the type. What we can do in this switch then is apply any settings for each command type that we want to do. So in this switch, the thing we're going to change is the speed, but we may have something more later on. So like for the slow, we're going to change the walk speed, and we'll put that in a function here. The only one that's missing from here is just the normal command move, and that will go through the default there and just set to run. And it's good to have something like that too if we have other things that want to utilize this. Then if we're not setting the command move type, then it'll just use the normal run speed. And after we've done that, we actually want to just issue a move command. We'll set up that function now. We'll put that in a protected. Let's set up our other functions as well for our sprint and walk. Now to do this, we're going to have to access the character movement component. So what we might do is actually assign a reference to that because we're going to be using it each time. So we'll put in a new property for the character movement component, and then we'll assign that on begin play. We can do that on the constructor. Oh, here we go. We're already using it. So what we're going to do is we're going to assign it here. And then we'll just change these to use that assigned. So while we're in the constructor here, we're just going to add a setting for the AI possession. So when the character's spawned in, it'll automatically possess with the AI controller, which we'll set to our type later. So back in our set walk, or all of these actually, we're going to just check that the character movement component's been set. Actually, there's one more thing we're going to need here, is we need to assign. We basically need to remember the max speed, because if we're going to change it, then we need to know what to come back to. So I'm going to set up this max speed variable and just assign the walk speed that we've got on the character at the start. So if we go down to where that is, just put in that float max speed, and then when we set our speeds here, we can just base it off the max speed. So we can set the max walk speed to half our max speed. And then, when we want to go back to normal, which is our run, we can just set that back to that max speed. And then sprint can be 25% of our max speed. So we'll go back to our command move. Basically, this is where we're going to talk to our AI controller. What we are going to want though is, there's a number of ways of setting up how to control the AI. And the lot of ones you'll see online is you use the behavior tree and you use the move node in the behavior tree and you just set a location and it moves to that location. But one thing we're going to want with an RTS is to know when they arrive at that location and do something when they arrive at that location, like orientate their direction and stuff like that. So you don't really want to just sort of have a fire and forget. The behavior tree updating locations like that is good for when you got you always see the one where they set up the AI chasing the player. That's constantly updating to the player, like each tick or whatever. And but yeah, it's not really ideal for what we want to do. we want to have a more, okay, we're moving now, and now we're stopped, and now we want to do this. And it'll come in later, you know, too, when they're moving and you want to play a sound when they arrive and all that sort of stuff. So we're going to do a setup for that. What we will need is we need to come back from the AI controller back to the character and then perform some sort of, you know, I've reached my destination actions. So we're going to set up a delegate for that. So if we go back to the H file, go to the top, and we're going to set up a delegate to pass back the command data, which will be the command data that we pass through when we issue the command. So the AI controller will keep that command data and pass it back when it finishes the command. So we're going to need a property for our delegate here. If you haven't used delegates before, it's sort of just like subscribing to an event. So for instance here, the AI controller is going to reach a destination and then just go, hey, anyone that's watching this and you care, I've reached the destination. And if you're listening, you run the function that you want to run. So basically, this character is going to say, okay, I'm going to listen for a character reaching the destination. And when someone says it has, I'm going to fire this function. Now what we need to do, we need to subscribe to that event. So what we're going to do is create a function for it. And we'll call it destination reached. Put up here. So when we reach the destination, we can fire stuff off here. That'll be where we initiate our rotation for us, but it could be play a sound, could be update a UI, could be a whole bunch of stuff. So what we'll do is we'll subscribe to it. So when we issue the command, first thing we'll do is clear it. So this will be handy for if the character's already in the process of moving to some destination and you click somewhere else, we'll just make sure we're not getting mixed up with what destination we're actually listening out for. And then if it's not bound, we'll bind it. So this is saying the on-reached destination delegate. We're adding this function for when this is fired. I think we'll just set up the orientation. So we're going to need a couple of parameters for the orientation. We're going to need the target orientation, which is because we don't want them to snap to it, so we're going to rotate to it over time. We just need to store the actual target rotation, which will be what's passed back in that command data. And then we'll just have like a Boolean. So should we be orientating? Because we're going to put this in tick. You don't want it just running all the time. Go up to tick now. So we want to check we should be orientating. And if we are, set orientation. Pass in delta. Set that function up in a second. One of the other things we have to do is once we do orientate, we're going to have to set that should orientate to false. So we'll set up this function as well. We'll just set up is orientated, which will check our rotation to see if we're facing the direction we should be. And if we are, we'll set that back to false. So let's set up those two functions now. So is orientated is going to be pretty easy. We just need to check if the yaw is the same, and if it's not, return false. So if our current yaw is at our target yaw, and that's a tolerance, probably put that a bit higher, but that'll do. That means we're facing the way we're meant to be facing, and we can just return true, and that'll stop our orientation from going on. Now for the set orientation, it's a very similar setup to what we have in the player pawn to do its rotation. Going to use the Gizmit Maths library, so it's included at the top. So if you followed on from the previous ones, you would have seen something similar to this, where we get the yaw and we get the pitch, but we just take out the roll, and then we're getting the target orientation and we're turning it at that speed. So this will calculate the interpolation we need in this tick to start rotating towards our target. It will just incrementally move the actor around. Now back in our destination reached, we'll need to set our should orientate to true, so that starts rotating. Before we do that though, we need to set our target orientation to the rotation passed back from the AI controller, which is the rotation target for our current command. So now on our command move, it's time to head over to our AI controller. So what we'll do is we'll set up a reference to our AI controller, which if you named it the same as me is SAI controller. We'll declare that, and then what we'll do is we'll set this from the AI controller itself when it's possessed. This allows us to access that AI controller in here, so we can say controller, and then whatever so we'll call the function command move, and we're going to pass our command data. And we'll need to include our AI controller that we created before. Go to our AI controller. First thing we'll set up is our constructor. Don't think we need to do anything in there just yet. So there's two functions that we're going to override on the AI controller. One is the onPossessed, and the other one is the onMoveComplete, which is how we're going to communicate back as to when we have finished a move. And obviously we're going to need that function that we just included, and it's going to have to be public so we can access it. And that's the command move that we just called from our player. Again, we need to include our AI data, and we'll need a property here for our owning character. So I'll add this under protected, whatever your character class name is, include a reference like that. And we'll also want a reference to our current command data so we can reference again later when the move's completed and pass it back to the character. So that'll be the first thing that we do here. We'll just set our current command data to the data that's passed in. So it'll always be the most recent command that's come through. And then we're just going to call the move to location, which is a built-in function in the AI controller. So if you have a look at this, part of the AI controller that we've inherited off generates a path and follows it. You can pass in acceptance radius and some other things, but the defaults are fine for what we want to do. Now the onPossess is like the begin play for an AI controller, is where you want to set up anything, because it's basically saying it's just been possessed by a pawn and it's valid now. So we're going to set up our reference. We need to include our player class. So I'm setting a reference to our character, and then if the character is valid, I'm going to pass back this controller back to that to set its own reference. Yeah, basically what we're doing is we're setting a reference to the owner of this AI controller, and then we're setting a reference to this controller on the owner. And it looks like I'm using a function here which I forgot to set up. So we'll go back to our character, and we'll just add will have to be a public function, won't it? And this will just be a setter, so we don't need to, we can just set this up in line, set AI controller, passing in a new controller, set that variable that we created before to the controller we're passing in. So now on the move complete, so I just realized I made a mistake here. The delegate that we set up on the character, this delegate is meant to be on the AI controller. Sorry about that. We're just going to move some stuff over. So this will go here. And then we need to bring over the delegate declaration. Nice in red for us now. This will be public. And then back on our player character, where we're assigning to that, we'll actually need to check that we have a reference to our, we should have been doing anyway, but probably why I made a mistake. Let's just do not return. And then this should be all pointing to our player controller. I don't think we need that actually. I'm going to take that out because we're clearing it anyway. So now the AI controller doesn't need to know about the character. That's how you're meant to use delegates. It's meant to be just a broadcast. You don't need to have a reference back to the thing. So on our AI controller now, on our move complete, we can just go on reached, destination, broadcast, and current command data. So now the AI controller doesn't care who's listening. Just says, hey, this happened. If you want to know about it and so you're subscribed to this, here it is. So in the AI controller onPossess, we actually don't need to store this character reference. We could just grab it briefly and pass it. But we'll leave it there for now because we might need it for something else later. So let's see if we can build. Right, so back in here, if you're using the data file, we're going to have to come into our input data. And this is where we just need to assign those new IA commands that we put in. Command and control command. Save that. So that'll make all our reference bindings work. And then we just need to set up our, oh no, we did the context, didn't we? So I think the last thing we'll do is just we'll create a new blueprint class, and it's going to be from our AI controller. So we're just creating a blueprint class of our AI controller that we created before. Call it this controller. And we'll just save that, and then on our AI character, whatever character you're using, so I'm using the top down for this one. In here, I'm just going to search for AI, and it's the very bottom thing here. Search on that. We just want to set our AI controller there. So you should already have placed in world or spawn, because that's the setting we set in the constructor, and we're just setting the class to spawn with. And the reason why I'm creating a blueprint class is just so we can go into it later and assign settings just that are specific to the AI controller only. Right, let's see how we go. So if you remember from the input setup, we had P to place a character. If you don't have that, you can just drag one in and have it there from the start. And now if we right click, we should move. And if we drag, we should face the other direction. Yep. There we go. And yep, so if we press shift, we should sprint. And alt should walk. And control doesn't do anything at the moment. And if you notice at the start, I left this in because you might wonder what happens. You notice the character move and it stopped, it didn't go to the destination. It'll probably happen if I come down here as well. See, I'm clicking, but I can't move down here. And the reason for that is, you might not have this, but the nav mesh, if you either press P, it works. Oh, there it goes. If P doesn't work, it's in here, show navigation. You can see I'm clicking off the nav mesh, and that's where I placed him was off the nav mesh, so he sort of took a while to get back on, and then the second time I clicked was on the nav mesh, and he was on the nav mesh, so it worked. So just be aware of that. It's quite easy to forget and wonder what the hell's going on, because they sort of move, but they don't sometimes. And so I'm just I'll set this to 0, and then I'll just times this by 5, because we've got big hills, maybe by 10 in height. And you can see there, it's auto generating. The reason why it's not generating here is it's too steep for the character to actually move up. But you'll see now that I got that going. One thing to watch out for too is when you go from the editor with that nav mesh on, if you've got a large nav mesh and like a large terrain, it can really hit your performance, even though I can't see the nav mesh while I'm playing. It's running in the background in the editor, so yeah, just watch out for that one. So I should be able to move everywhere now, including up some hills. Let's run up the back here. Here we go. If you see at the moment, we tell these guys to move somewhere, they are all going to go in the same position. Well, they're not doing too bad. Sometimes they can fight for survival, who's on the point, and they start getting into a crazy rotation and doing some funky things. But so in the next video, we'll handle actual formations with the units, so they don't bunch up like this, and we'll just cover some different types of inputs that you can do and different things that you can handle in combination with movement. This project's available on Patreon to our Patreon members. I want to thank the current Patreons for your support. Please don't forget to like if you found this tutorial helpful, and subscribe so you don't miss out on future tutorials. You can join me on Discord or sign up to my Patreon, where you can get access to all my tutorials early and the project files, as well as gain access to behind the scenes on my current game development. If you have any questions, leave them in the comments. Thank you for watching. See you next time.